Hey guys, so at some point this year you're going to be making your own solutions for labs. And so I'd like to go over some of the basics for that. Before we do anything, we should probably talk a little bit about the metric system, just a quick review. So here are kind of symbols and prefixes and all of that. The ones that we normally use in this class are going to be milli, micro, nano, and kilo. Remember that you add those to your base unit, and the metric system is really nice because as you convert from one unit to the other, you're really just moving the decimal place. The biggest question you have to ask yourself when you are converting is, does this make sense? Because you're changing by powers of 10, you're making big changes, but you have to make sure you're making them in the right direction. So if you're converting to a smaller unit, you're going to likely move the decimal place to the right or multiply. If you're converting to a larger unit, then you're going to go in the other direction. But again, biggest question to ask yourself is, does this make sense? Some of the units that we're going to use in biology are meter, liter, gram, second, and then Celsius for temperature. It is important that you're using the correct units. So no Fahrenheit, no ounces. These are going to be the units that you use. So let's just do a quick review, take a minute, see if you can answer these. So I'm going to go through and do them with you. So 15 milliliters is equal to how many microliters? So there's 1,000 microliters in a milliliter. This is going to be the smaller, oops, sorry, you can't see that, the smaller unit. And so I'm going to move my decimal place 3 places in this direction. So it would be 15,000 microliters. And so, again, ask yourself, does that make sense? Yeah, that kind of makes sense. These are really tiny. Next, you had 1.5 meters to kilometers. Okay, well, meters, kilometers is a bigger number, or bigger unit, right? A kilometer is like you measure how far you drove in kilometers, and meters are much smaller. There's actually 1,000 meters in 1 kilometer, so I'm going to move it 1, 2, 3 places. And so my answer would be 0.0015 kilometers, and again, that makes sense. Next, you had 235 milligrams to grams. So milligrams is the smaller unit, grams is the larger unit. There's 1,000 milligrams in a gram. So you have 1, 2, 3 decimal places, so it's 0.235 grams. And last but not least, 0.25 liters is equal to how many milliliters? Well, there's 1,000 milliliters in a liter. Milliliters is the smaller unit, so I'm going to move in this direction. So that would be 250 milliliters. So hopefully you feel pretty comfortable with that. If not, then make sure you see me so we can review it. So again, if we're making solutions, a solution is a solvent plus a solute. Generally, we say that the solvent is going to be water, and the solute is the stuff that you dissolve in the water. So the concentration is how much stuff in the overall volume of solution. Sorry that got cut off. So again, water is going to be the solvent, the stuff that you're dissolving in it is your solute, and the concentration is how much stuff in the overall solution. So stuff per unit volume. Now there's different ways to measure concentration. One is looking at your mass volume concentrations, and so that's exactly what it sounds like. We measure like grams per milliliter or grams per liter of solution. Milligrams per milliliter, and so you're talking about the mass of solute in a certain volume of solvent. So if you're dissolving sugar in water, the sugar is going to be your solute, and your solvent is going to be the water. Now, if we wanted to make some solutions with this, there's some different ways that you can do those calculations. So you can multiply the concentration desired by the volume desired to get the mass of solute that you need. I am a fan of the conversion train because that lets me really kind of visualize what I'm doing and make sure that I'm not missing any steps. And so let's look at this next problem and see if we can solve it together. And I'll kind of go through how I would solve it. So a technician needs 50 milliliters of a 15 milligram per milliliter pepsin solution for an experiment. So now let's see how we can actually make that. So we need 50 milliliters of a 15 milligram per milliliter solution of pepsin, right? And really what we want to know is how many milligrams of pepsin do I need to measure out? So I want to get to milligrams of pepsin. So I'm just going to write that at the end to remind myself that that's what I'm dealing with. I have 50 milliliters is the volume that I want. And the concentration that I want is 15 milligrams for every 1 milliliter. Now, I like setting it up this way because I can look and see if I have units on the opposite side, then I can cancel those units. And then I'm left with milligrams, which is good because that was the unit that I wanted to get to in the end. So now all I need to do is multiply across the top, multiply across the bottom, and then divide whatever my answer from top, whatever my answer from bottom. So 50 times 15, and I'm going to use my calculator. 50 times 15 is 750. Divided by 1. And so my final answer is that I would have 750 milligrams of pepsin needed. Now, that's all good if you're just solving a problem on paper, but in the lab, if you need to actually make this solution, what's your next step? Okay, so what you're going to do is you're going to weigh out 750 milligrams of pepsin using a scale or a balance. And you're going to add it to some sort of graduated cylinder or something that has actual markings on it. And so you're going to first put that 750 milligrams of pepsin into your container. Then you're going to pour in water, distilled water, until you get to that 50 milliliter mark. So remember, your meniscus will be at 50 milliliters. So this is different than just saying 50 milliliters of water plus 750 milligrams of pepsin. It's a small difference, but it's kind of a big deal. It means that you're making the solution properly if you follow this procedure. So remember, you add your solute and then you fill till the whole thing equals 50 milliliters. All right. So another way of measuring concentration is by talking about the molarity of the solution. And so that's how many moles of a particular compound per liter of solution. So don't let that scare you, because we're talking chemistry and moles, and you see that 6.02 times 10 to the 23rd. It is just a unit of measurement. It is a way of measuring out a certain amount of a particular compound. And this is actually the one that we're going to be using in our next lab. So a mole of any compound or any element is equal to 6.02 times 10 to the 23rd molecules or atoms, depending on what you're dealing with, of that element, which doesn't really mean much to us, but it is a way of measuring the amount of stuff that you have. And it's actually pretty easy to figure out this molar mass. You just look at the periodic table. So when you look at the periodic table, so I'm going to click over to our periodic table if you remember this. You'll notice that you have these atomic masses here. So here I'm going to look at making a molar solution for sodium chloride or table salt. So I've got sodium here at 22.99, so I'm going to call that 23 atomic mass units. And then I'm going to find chlorine, which is over here, is 35.45. I'm going to call that 35.5 for my calculations. So really you're just looking at the mass of that element, and since sodium chloride has sodium and chlorine, I'm going to add the 23 plus 35.5. That is it. Don't let it become something that's intimidating. So if the molar mass or molecular weight of sodium chloride is 58.5, because I added 23 to 35.5, that's in atomic mass units. But if I want to know the mass of 1 mole of salt, I just make that grams. So 58.5 grams of sodium chloride means that I have 1 mole of sodium chloride. That's it. It doesn't have to be scary or complicated. To determine the molar mass, you can add up the masses of the elements, or you can Google it. So for our lab, we're going to be using sucrose. You can look up the molecular formula of sucrose and then add together all of the masses times the amount of each thing. Or you can just look up the molecular weight or molar mass of sucrose. Google will tell you the answer. If you need a little bit more, I have these links in the presentation on Blend, and I'll also put them into the assignment. Those would be a good place to just do some review on moles if that's something that you feel like you didn't really understand the first time you did it. So again, the periodic table is your friend. It has some good information. So is Google. So here's kind of if you just multiply out. Again, I'm going to show you my conversion train method for this. So let's see. A technician needs 50 milliliters of 0.5 molar sodium chloride solution for an experiment. So we're going to need excuse me. We're going to need to remember that sodium chloride has a molar mass of 58.5 grams per mole. Okay, so now that I have that, I can come over, I see my question, I am going to switch over to my paper and we're going to solve this problem together. Okay, so let's see what information I have. So 1 mole of NaCl, or sodium chloride, or table salt, whichever you want to go with, is 58.5 grams. 58.5 grams. And again, I just got that off the periodic table. I need 50 milliliters of 0.5 molar NaCl. Now I need to know what are the amounts of everything that I'm going to need to do that. So basically I need to know how many grams of sodium chloride do I need to weigh out in order to make this 50 milliliters of 0.5 molar solution. Okay, so I'm going to make my conversion train. I want grams. I know that I want 50 milliliters. And this is 0.5 molar NaCl. Now the one tricky thing here is that I want 0.5 moles of NaCl, but a molar calculation is per liter, so in 1 liter. So that's what molarity kind of measures, that's moles per liter. So, and I know that there are 58.5 grams of NaCl in 1 mole of NaCl. Now I could put the grams on the bottom and the moles on the top, or vice versa, since these are equal to each other. However, because I have moles here, I want my moles down here. So because they're on opposite sides, remember if they're on opposite sides I can cancel my units. I have grams of NaCl, which is what I want, but I'm stuck here because I have milliliters up here and liters down here. In order to kind of get rid of those units, I need a liter and a milliliter. So I know that 1 liter is equal to 1,000 milliliters. And because those two are equal, it's like saying multiplying everything by 1, right? Because those values are equal. And now because I have liters on both sides here and milliliters, I can cancel out. There are other ways to do this. This is the one that I still use because it keeps me from making like a silly mistake or forgetting something somewhere. So now I've taken care of all my units. Now I just need to worry about numbers. And so I'm going to calculate across the top and then calculate across the bottom, like multiply across the top. So 50 times 0.5 times 58.5 times 1 gives me 1,462.5. And then on the bottom I have 1 times 1 times 1,000, so that's going to be 1,000. So top divided by bottom, I'm going to move my decimal place 3 places, and that will give me 1.4625 grams NaCl. So again, next step in the actual lab would be to measure out this many grams of sodium chloride. So how many grams sodium chloride? So again, I'm going to go into my graduated cylinder or measuring cup or whatever you're using to measure this. And I'm going to add that many grams of sodium chloride, and then I'm going to fill to that 50 milliliter mark with water. All right, so now that you figured out how to make a molar solution, we're going to talk about diluting that down. So for the lab coming up, you're going to need multiple concentrations of your sucrose solution. So you're going to need a 1 molar, a 0.8 molar, a 0.6 molar, a 0.4 molar, a 0.2 molar, and then a 0 molar, which is just distilled water. And so in order to make all of those solutions, you could measure out the sugar and then add the water and go through that whole process each of those times. But a better way to do that is to make a dilution of a concentrated solution. So we actually call that concentrated solution a stock solution. In most labs, most of the stuff they have in the back is a concentrated solution or your stock solution, and then you dilute down from that. And it's actually pretty easy. You're going to follow the C1V1 equals C2V2 method. So C stands for concentration and V stands for volume. And essentially what you're looking at is your initial concentration, so this is your stock solution, and then your final is the C2V2. So again, you want to know how much of this stock solution do I need, and then how much water do I need to add to that. So let's take a look at this question. So again, we're working with sodium chloride in this example. So let's say we have a 1 molar stock solution of sodium chloride. That's going to be my C1. And you want 200 milliliters of a solution with a concentration of 0.4 molar NaCl. So that's my C2. So really what I'm looking for is how much of that stock am I going to use to make that total volume. So I have my C1 is going to be equal to 1 molar NaCl. My V1 is going to be my unknown. My C2 is going to be 200 milliliters. Oop. My V2 is going to be 200 milliliters. And my C2 is going to be 0.4 molar. So let's go over to the paper and work it out together. Alright, so C1V1 equals C2 times V2. So I know my C1 is 1 molar NaCl. My V1 is my unknown. I know what concentration I want, so that's going to be 0.4 molar NaCl. And I know my final volume is going to be that 200 milliliters. So I want to have 200 milliliters of 0.4 molar solution. So now I'm going to solve. So I'm going to 0.4 times 200. I'm going to use the calculator just in case. Gives me 80. So I have 80 moles times milliliters. And then I'm going to is equal to 1 molar NaCl times my unknown. So now I'm going to divide by both sides by 1 molar, because that's the stock concentration. That's my C1. So I can cancel the moles. 80 divided by 1 is 80. So my V1 is going to be 80 milliliters. So what does that actually mean? That means that I'm going to take 80 milliliters of that stock solution. So there's going to be 80 milliliters of my 1 molar solution. And then I needed a total of 200 milliliters. So I'm going to add, so 120 milliliters of distilled water. And that D just means distilled water. So that gives me my total 200 milliliters of 0.4 molar NaCl. And so this is going to be the way that you make those dilutions. So you'll make a 1 molar stock solution, and then from that you'll dilute down to all of the other concentrations. So I hope that was helpful. If you have any questions, I'm happy to go over those with you again when we get to class. Have a good day.